And here we see a video of all the steps, but without the calculations, because we couldn't do any calculations while we were following the ball with the camera. But we do know that a lot of mechanical energy is happening here, where potential energy is converted to kinetic energy. This is a general theme in our Rube Goldberg machine, where that potential energy is converted to kinetic energy, and some is lost to friction, which is thermal energy. Nonetheless, let's proceed. Yeah, here we saw how the orange ball, which we recorded, goes down the ramp, hits the candle goes on the balloon is heated and it explodes. And here is the scientific video, where we see the orange ball rolling down the rail, where we see the potential energy is converted into kinetic energy, of course, and then we tracked it and made Lucker Pro do some calculations for us and do some graphs. But here we just see the tracking of the ball. We see here is the orange ball, which we will be tracking, and up here there will be a marble falling down, hitting the orange ball and making it move. So let's see how it looks. The marble, the orange ball, you can see here the dots are starting to have a bigger gap between them, which means the kinetic energy is increasing. Here we see there's big gaps between the dots, which is where there's the most kinetic energy. And at this point there is no potential energy left, and all that's left is kinetic energy. And then it starts, here the dots get smaller because energy is lost to friction, and also some is lost to, goes from kinetic to potential energy because the slope is going slightly upwards. This is converted into, there's also the friction, which is thermal energy, and the sound from when the candle is hit, which is sound energy. And then in the end, we see the dots have smaller gaps. In the end, the ball stops, and all the mechanical energy that's left is a bit of potential energy, because yeah, there's a slight uphill here thingy majiki. And also important notion is we see how these dots don't follow, they like move around on the picture, and that's because the camera was not completely still when we were filming, which made the data not completely correct, but the graph will still show what we wanted it to show. Here we see the graph. We see the blue dots with the potential energy, and for a while it's constant because nothing is happening in the video. And about here, the ball is hit by the marble, the golf ball, and the potential energy starts decreasing all the way to 0. And meanwhile, the kinetic energy is increasing all the way up to about 0.15. And the marble comes about when 7 seconds has passed. And we see this, the x-axis is time and the y-axis is the different energies in joule. And the mechanical energy is the same as the potential energy up until this point, since the kinetic energy is 0. And at this point it starts decreasing, and because the energy is lost to friction. And this point it decreases drastically because it's the candle is hit and a lot of friction is happening. And in the end, all the three energies are about the same, but you can see that mechanical energy and the potential energy is a bit more than the kinetic energy, and that's because of the fact that there's a slight slope in the end. Uphill, of course.